Okay, now in this question we're being asked to work out some possible Lewis diagrams, two possible structures for the product, and we've got NCO minus, which is going to have an H plus come in and bond to it. So we really need to work out the Lewis diagram, or the Lewis dot diagram, for NCO minus to start with. Now obviously if we work out the total number of electrons, we get 16 electrons, including the electron for the negative charge. And you can go through a process of trying to work out what Lewis structures are possible. Now the carbon atom is obviously going to be the central atom. Now the more electronegative atoms here are going to be on the outside, and carbon is usually a central atom which has other atoms or groups bonded to it. So going from here we can come up with some different possibilities for Lewis diagrams. Now in fact, if you were to go through this process, you'd end up with three possible diagrams. Oops, it's not that right there. And I'm just putting the electrons around here. That's got two. So really, if you look at this, these two are very similar, in that we have a triple bond, but we're just swapping it from one side to another. And in this one we have two double bonds on this side. Now this is not what it means by the two possible structures. The two possible structures, what it's referring to is that we can have either an H plus, which obviously doesn't have any electrons to it, so it can either bond here and we'd just see those two electrons disappear and become part of a bond to the H, or if we had it come in on this side, we'd just see it bond to, say, maybe those, and we'd just have it straight bonding to the H there. So that's what that's really meaning. So we've just got to decide before we even get to that stage, which one of these structures is the most likely one that we're going to finish up with. Now this is a little bit more awkward than it looks, and it really introduces a concept which probably hasn't been taught, and that's one called formal charge. Formal charge is a way of assigning a number to each atom, and we really want it to be as close, or if not at zero, as possible. And we can assign them to each element, each atom rather. So we basically, to do that, I'll just get rid of that. There's a system where you basically have the valency number, the number of electrons it normally has for that atom, and you subtract the bonds. So a double bond counts as 2, single bond counts as 1, and the lone pair of electrons. So for instance, in this case, for the oxygen here, there's 3 lone pairs, but that would actually count as 6 electrons. So the lone pair electrons count in there as well. So for instance, this nitrogen has a valency number of 5. So, and we've got 3 bonds and 2 lone pairs of electrons. So it would be 5 minus 5. So that would have a formal charge of 0 in that case. The carbon has a valency number of 4, and if we subtract the bonds, that's going to be 4 minus 4. That will equal 0 as well. This has got 6 as being the valency number of electrons, so 6 minus 1 plus 6 is 7. It equals -1, so there's a formal charge of -1. So that's not too bad, but obviously it would be better if we could get them all equal to 0, if that was possible. Now in this case, on the other side, we have 5 minus 1, and 6 is 7. So 5 minus 7 is -2. I think I've got that right. And again, 4 minus 4 is 0, so that's 0. And this is going to be 6 minus 1, 2, 3, 4, 5. And 6 minus 5 is going to be 1 plus 1. So immediately we can kind of get rid of this one, because we've got formal charges which not as good as 0, 0, minus 1. Now, one thing to keep in mind is just your general knowledge of organic chemistry and knowing that carbon often has a triple bond to nitrogen. Obviously it can singly bond with things like amines, etc., but triple bond is quite common. Now, on this other one actually is a little bit more difficult. We get 4 minus 4 is 0 for the carbon here. We get 2, 4, and we've got 5 minus 6, and that equals 5 minus 6 is negative 1 here. So, and then we've got 4 minus, oh, it's not 4, 6, sorry, minus 1, 2, 3, 4, 5, 6. So that's 6 minus 6 equals 0. So this one, in some respects, is no different. But this is where your knowledge of chemistry and knowing, have you ever seen a structure like this, which is going to be the more likely? You know, is it more likely to see an H coming in bonded to something with like a single bond to an oxygen or a nitrogen? Has this structure ever been seen? Now, without any further data, because obviously these bonds would actually be of equal length, they're both, or actually I don't know if they would, but they would be shorter than a single bond. That would, a triple bond would be shorter still, that would be a longer bond. So as you get more electrons in here, the bond actually gets stronger and the distance gets shorter, but we haven't been given information to work that out. So looking at this, just my knowledge of organic chemistry tells me this is an unlikely structure to see. So really, the only thing that formal charge really helped with was differentiating these two. Okay, now just redrawing this, if we have, I'm just going to do that exactly the same to start with, but if we have an H plus come in from this side, this bond, I'll get rid of that lone pair of electrons and they'll end up, if I can, and that'll end up bonding an H to there. Now if we have an H plus coming in on this side, we'll get rid of this bond here. We'll end up with an H on that side. So now when we look at this, it says us that it's got a bond angle of 105 degrees for the one that the H is attached to. Now in this structure we've got obviously that bond angle there is not going to be 105 degrees. This one here though, we've got around the oxygen, we've got two, it's based on a tetrahedral shape, so it's going to in fact be 109 degrees, but because we've got two non-bonding pairs, that increases the electron-electron repulsion from those lone pairs, and that would bring it close to 105 degrees. So that one's right. This bond angle around here on the nitrogen, we've got basically two bonding pairs, so that's more likely to be 180 degrees, isn't it? So that's the correct structure. So that's how you'd identify that. So it's a little awkward, that question.